good morning or good afternoon. All right, it just depends on when you're watching this. Okay, so yes, this review was on Edulastic, Final Review 1, numbers 1 through 13, but it's important that you write down your work the way that I show you, okay? Because you need to make sure that you show work just like this when you take your final. And a lot of you guys are really bad about using every square inch of your paper but not labeling a darn thing. So it's so hard for me to figure out where things are. So I'm doing it this way. If you need more paper, then you need more paper. I've got plenty of paper. You're gonna be fine, okay? All right, so number 1 says, consider the figure given below. If the square is rotated about the line L, the solid object formed is A, and there's a drop-down menu. So for number 1, now on the test, you could just write down what your answer is. But for here, because it's a review, we need to show our work, okay? These are all right angles. And we're going to be rotating around line L. This is line L. We're rotating around line L. And what's going to happen is, this is a 3 by 3 square, that means that this square gets rotated around, and when it gets rotated around, it makes a cylinder. So the object formed is a cylinder. That's the first answer, okay? There's a part B. So after part B, it says, what can we infer from the three-dimensional object formed? Well, before we even look at the answer options, look at what we've got here, and we can make a list. First of all, we know that the radius of the cylinder from the center of the circle to an edge is 3, which means that the diameter from edge to edge of the circular base, 3 plus 3 is 6, okay? We also know the height of this cylinder is how tall it is. Well, it's still only 3 units tall, so its height is 3. So the first answer option is, object is a cylinder with radius 3 units. Yep, A is correct. Object is a cylinder with radius 6. Nope, we already said the radius is 3. Object is a cylinder with diameter 3. Nope, the diameter is 6. Object is a cylinder with a height 3. Yes, so you had to select D also. Object is a cylinder with a height of 6. No, we already said the height is 3. So A and D were the correct options there. Okay, so when you're going through these for the reviews, this is what I expect to see, okay? And then we'll section it off for number 2. On the test, I'm not so much worried about the picture, but at least writing down the things that you know that you are selecting, okay? Letting me know that you know it's a cylinder, letting me know that you know what the radius, the diameter, and the height are, and which answer options you selected. Because sometimes also you select A and D in your mind, but when you do it on the test, you accidentally click B and D instead, or something like that. I need to know if you're making those mistakes, because some of you guys do make those little tiny mistakes, okay? All right, so next, number 2, is Frank the farmer has a variety of weather vanes that sit atop his barn and silos. They're nothing fancy, simply a 2-dimensional object attached to a vertical pole. Where Frank is at, it tends to get very windy and blustery, making the wind direction swirl and shift very rapidly. On some days, the weather vanes spin around so quick that Frank can catch a glimpse of what looks like a 3-dimensional solid. Match the weather vane to the solid it would create by rotating around the vertical pole. Okay, so for number 2, this is the drag and drop question, okay? So I'm gonna be dragging and dropping. Oh, I need to refresh my page because I can't see the first one. But anyways, when you spin, come on, reload. When you spin something around, it's gonna make a 3-dimensional object just like we did up here. So hold on, mine's reloading. Oh, hold on just a second. Making me look at it again because I'm on the slow Chromebook because we got hacked. There it is. So the first picture looks like this. So you spin that around that pole and it's going to make a cone. Okay, so you would drag and drop the cone. For the next one, we have something that looks like this. You spin that around, the same thing that happened in number 1 is going to happen. We're going to get a cylinder. So you have to drag and drop the cylinder. The third one is the double triangle thing, like a helix. Okay, so when that spins around, it's going to make a double cone. So it's going to make a cone like this, and a cone like that, a double cone. I don't know what to call that other than a double cone. Okay, but see how I'm showing my work? Like, this is what I'm expecting to see. And then if we spin that half a sphere around that pole, we're going to get a sphere, or a half circle around, I'm sorry. I want to get this dimension. So, and I'm also going to write sphere. I didn't really need to draw a picture of a sphere, but I felt like it, so I did it. Okay, so the 4 drag and drops that we did were the cone, the cylinder, the double cone, and then the sphere. And that was number 2. Now I'm writing big. You could probably fit more on one sheet than what I am, but still, like, this is how I want you guys to lay out your work, okay, so that it's easy to follow. And you don't necessarily need to put the little squigglies through, but I like sectioning off so that I know, hey, I use this space for number 1, this space for number 2, and so on. All right, number 3, it says, given the function g of x equals log base 2 of x minus 3 minus 5, identify all the following points that would fall on its graph. So it's a select all that apply problem. And what we need to do is we need to make a table of values, and we need to test out the x values that they gave us. They gave us A, B, C, D, E, and F. The x values are -1, 3.5, 1, 2, 5, and 4. And we need to test these out, which means we got to plug them in and see if the answer we get is the y value that they're matched with in their ordered pairs in these answer options. So number 1, or plugging in a -1 for x, I'll use a different pen, I will have log base 2, remember it's all about the base, and the base is a 2, of -1 minus 3 with a minus 5 on the end. Wait a second, -1 minus 3 is -4. We can't plug in negatives into a log. This gives us error. So automatically, that's a throwaway answer. That one doesn't work. Okay, let's try the next one. So plug in the 3.5 for x. So log base 2 of 3.5 minus 3 leaves me with a half. So I'm just going to go ahead and do the subtraction. Hey, a half and a base 2, those are similar. We have to just undrop that like it's hot. So that would be log base 2 of 2 to the -1 power. Remember, negative exponents make fractions, minus 5. The double base cancels, so it's just the exponent minus 5, so -1 minus 5 is equal to -6. Is that what it matched up with? Yes, it is. So B is one of the answer options. And then you click it. All right, and then the next one, we're plugging in a 1. Well, log base 2, 1 minus 3 is -2. Uh-oh, error again. So that's not it. We can't plug in negatives into a log. All right, next one. Plugging in a 2. 2 minus 3, that's a -1. We're going to get error again. So we can't plug in a 2. Can we plug in a 5? Yeah, we can. 5 minus 3 is 2. So log base 2 of 2 minus 5. When there's no exponent on a number, we assume it to be a 1. The double base cancels out, so then it's just 1 minus 5, which equals -4. And does 5 map with -4? Yes, it does. So E is another answer option you need to select. And then the last one, number 4, log base 2. 4 minus 3 is 1, and then that minus 5 on the end. Well, to get a 1, that means that 2 had to have been to the 0 power, because anything to the 0 power is equal to 1. So 2 to the 0 and 1 are equivalent. And I did that because I need this double base. So then I have 0 minus 5. 0 minus 5 is -5. Did 4 map with -5? Yes, it did. So F was another answer option. So the answers were B, E, and F. It was a select all that apply problem. So you had to select those 3. And that was number 3. Number 4, the drag and drop one. Let me see, how do I want to do number 4? Now on this one, I don't want you to write down all that. That's going to waste a lot of time. This one you have to show work for. For number 4, I'm just going to show you on the computer and hopefully it'll show up okay. The only thing is that it's doing that little blinky thing because it's a computer screen. So hopefully that doesn't make you dizzy or anything. Okay, so I should have fixed this. It should work because I have only these answer options so that if we end up needing to use one twice, we should be good, okay? So sine of 5 pi over 3, you know what, we might need to write this down. We need a unit circle. So the first thing I need for number 4, and I'll just use the back of this paper, is a unit circle. And since it's asking for 5 pi over 3 and I see 2 pi over 3 coming up, I'm gonna just put on my unit circle what I need. So I'm gonna need a 5 pi over 3. I know that that's over here in the 4th quadrant because this one is 4 pi over 3 and this one up here is 2 pi over 3 and this one up here is pi over 3 because I know my unit circle. So I need the coordinates here. At 5 pi over 3, it would be a positive x and a negative y. So that is a positive 1/2 and a negative square root of 3 over 2. All right, so this helps me because the sine is the y value because cosine is x, sine is y. So the sine is negative square root of 3 over 2. So I know what to drag and drop here. So negative square root of 3 over 2, dragging and dropping. The next one is cosine of 2 pi over 3. Well, 2 pi over 3 is up here, and I know that it's the same coordinate as this, except the x is negative and the y is positive. And it asked me for cosine. Oh, I didn't need 2 parentheses there, but whatever. Cosine's the x value, so it's a negative 1/2. So I have to drag and drop the negative 1/2 down here. There it is, okay. Next is sine of 3 pi over 4. 3 pi over 4, well I know pi over 4 is over here. 3 pi over 4 is over here. So I know that this has a coordinate negative square root of 2 over 2, positive square root of 2 over 2, because we're in the 2nd quadrant. And it asked me for the sine. Sine is the y value, so it's a positive square root of 2 over 2. So I'm going to drag and drop the positive square root of 2 over 2. All right, and then 7 pi over 6. 7 pi over 6, let's see. Regular pi over 6 would be here. 5 pi over 6 would be here, which means that 7 pi over 6 would be there. So that's 3rd quadrant. Everything's negative in the 3rd quadrant. And 7 pi over 6 is the reverse of a pi over 3, so it's going to be negative square root of 3 over 2, negative 1/2. Remember, they're both negative because we're in the 3rd quadrant, but I'm switching the 1/2 and the square root of 3 over 2 because we're not dealing with a pi over 3 anymore. It's pi over 6. It asks for the cosine. Cosine's the x value, so negative square root of 3 over 2 again. So I just need to go to the only one that's on my list and drag and drop it. 5 pi over 6 is next. Sine of 5 pi over 6, that's over here. So it's the same as these coordinates, except the x is still negative, but the y is positive in that 2nd quadrant. It asks for the sine. The sine's the y value, so I have to drag and drop the 1/2. So 1/2, drag and drop. Sine of 5 pi over 4 is next. So I have 3 pi over 4. 5 pi over 4 is in the next quadrant, down the 3rd quadrant. And everything is negative down there, so that's negative square root of 2 over 2, negative square root of 2 over 2. And it asks for the sine. Well, it doesn't matter, both sine and cosine are both the same in that case. So negative square root of 2 over 2 is what I need to drag and drop. And then cosine of 7 pi over 4. 7 pi over 4 is in the 4th quadrant. X is positive, y is negative down there, so square root of 2 over 2, negative square root of 2 over 2. It asks for the cosine, so that's the x value. I need a positive square root of 2 over 2 to drag and drop, and that's right here. All right. Next is sine of 2 pi over 3. Sine of 2 pi over 3 is the y value at 2 pi over 3, and it's a square root of 3 over 2, a positive square root of 3 over 2. So that one's at the bottom there, drag and drop. And then sine of 3 pi over 2, well, pi over 2 is up here. 3 pi over 2, oops, is down here at 270 degrees. That coordinate is 0, -1. The sine is the y value, so it is -1. And I need to drag and drop that -1 down there. And we shouldn't have any issues with this question marking us wrong anymore. All right, so that's number 4. So for number 4, you do need to show work. It's just you're getting your information from the unit circle. So you don't need a full unit circle, although I almost used a full unit circle. And that's number 4. And probably, since I have that space right there, I'll probably use number 5 up there. We'll see how much I need for number 5. Number 5, it says find an equation in vertex form for the parabola with, they're giving us a focus of 1, 4 and a directrix of x equals 5. Okay, let me adjust this a little bit. Okay, so we need to draw a picture. So here's 1, 1, 2, 3, 4. So there's my focus. X equals a number means it has to go through the x-axis at that value. So 2, 3, 4, 5. So remember, directrix is a dashed line. And the vertex should be smack dab in the middle. So let's see, that's 1, 2, 3, 4 units. Half of 4 is 2. So that means my vertex should be right there at the coordinate 3, 4. So my vertex is 3, 4, which means that my parabola needs to be facing to the left because it wraps around the focus and the directrix is always behind it. So this distance, or this distance, that's our p-value, and because it's facing left, it's a negative, so it's a -2 p-value. Okay, so this is a sideways parabola, which means we have to use the sideways formula. X equals 1 over 4p, y minus k quantity squared plus h. That's the formula we have to use. Okay, so x equals, we know the p-value is negative, so I'm going to throw that negative out front of that fraction because that's where you put it. 4 times 2 is 8 times y minus the hk comes from the vertex. The k is a 4, so y minus 4 quantity squared plus h, so plus 3. And that's what you would have to type into the box on Edulastic. So there's our answer for number 5. Okay, number 6. It says find the equation of a parabola with focus, focus 0, 1 and directrix y equals -1. Okay, so we're going to need to draw a picture again. So I just need a graph, 0, 1, that could be my focus. Remember, a focus is not the same as a vertex. Y equals means it has to go through the y at that value, so my directrix is the dashed line that goes through the y there, which means that the vertex should be smack dab in the middle, which means it's at the origin, and we all know the origin is 0, 0. So this parabola must be facing up because it wraps around the focus and the directrix is always behind the vertex. And so this also tells us that it's facing up. Up is positive, so our p-value is a +1. Remember, the vertex gives us the hk, and that's all the things we need. This is a vertical parabola, so I just need y equals 1 over 4p x minus h quantity squared plus k. That's the formula we use for an upward facing parabola. And so we just got to plug it in. So y equals, the p-value is just a 1, so it's just a 1 over 4 because 4 times 1 is 4. X minus 0 is just x, so that's going to be an x squared, and I don't need to put plus 0, so that's it. This is my equation for this parabola. Number 6. Since I have that space, I'll put number 7 over here. Number 7, it says consider the pair of functions given in the first column. Determine if the two functions are equivalent after expressing the functions in logarithmic form and comparing them. So we have exponential form to logarithmic form. So let's look at pair number 1. Pair 1. Okay, so we've got y equals 2 to the x and x equals log base 2 of y. We need to see if they are congruent or not. So you have to do your roundabout. So I would start with the log 1 because we usually need the log on the left-hand side. So I'm just flipping it like a pancake. And then we do our roundabout counterclockwise. So that would be 2 to the x is equal to y. Well, that matches. So pair 1 is a yes. So you would type in yes in the box. Okay. Pair 2 is y equals 1/2 to the x, and it says it's equivalent to x equals log base 2 of y. But we already said log base 2 of y is congruent or equal to this. So there's no way it can be equal to this completely other thing. It's a fraction raised to an x power. So automatically, that one's a no. Can't be two things at once. Pair 3 is y equals 4 to the x, and x equals log base 4 of y. So if we do our roundabout, now if we have it on the right, you just have to go around clockwise instead of rewriting it. So that would be 4 to the x is equal to y. Well, that's the same thing here. So this one is a yes, they are equivalent. And then pair number 4, it already says no in the answer box, so you don't even need to look at it. But it's a y equals 1/6 to the x versus an x equals log base 6 of y. Well, we know that would be 6 to the x power equals y, not 1/6. So it makes sense why it's a no. So it was yes, no, yes. Put number 8 down here. It says solve the equation. Okay, I'm probably going to use all this space right here. Log base 4 of x plus 4 plus log base 4. Sorry, that's a log base 5. I can't see because it's small. Log base 5 of x equals 1. Okay, first things first. I see x's in 2 spots and I need them in 1 spot. Plus meant to do something. It was a product rule of logs. When we are adding 2 logs together, we multiply their inputs. So I can condense this down to log base 5 of x plus 4 times x. I like to write the single term out front because it's little, equals 1. And now I want to get that stuff out of the parentheses there, out of the log. So the only way I can do that is inverse it, which means I have to take a base 5. This is a log base. I need an exponential base. But whatever I do to one side, I got to do to the other. The double base cancels, and then let's go ahead and distribute these. X times x is x squared. X times 4 is a 4x. On the other side, 5 to the first power is just 5. Now, anytime you get a quadratic, you need to get equal 0 on one side and everything else on the other. So I'm going to subtract 5 from both sides, and I'll come up here because I'm running out of room, and I'll get x squared minus 4x. Oh, sorry, that's a plus 4x, and then a minus 5 equals 0. Okay, I'm going to go the product sum route, although you could use quadratic formula if you prefer that instead. And let's see, the product is -5. The sum is a 4. So I need 2 numbers that multiply to 5 that add up to 4. Well, it's got to be 1 and 5, but it needs to be a -5, but it needs to add up to a positive 4. So that means the negative should be on the 1, because -1 plus 5 adds up to 4. These are the droids I'm looking for. It's an easy trinomial, so we get to just pop them right in. So x and a -1, x and a plus 5. And then we break them apart and set them each equal to 0 and solve. So x is equal to 1 is one solution. X is equal to -5 is the other solution, but we have to check for extraneous. So which one are we not allowed to use? Well, we can't take the log of a negative number. So I can't plug in a -5. So this one is a no-go. That one is extraneous. So this one is the only correct solution. x is equal to 1. And it does ask you to find the extraneous solution, so you would select from the drop-down menu x equals -5. Okay. Number 9. We've got a right triangle. Just drawing the picture. We've got a vertical side of 3, we've got a hypotenuse of 25, and we've got an angle at x degrees. It says, which trig ratio would you use to solve for the missing angle measure? So if I'm looking for this angle, then I've got this side that's adjacent to the angle, and the hypotenuse, adjacent over hypotenuse, is the ka of SOHCAHTOA, so that would be cosine. So cosine of x is equal to 3 over 25, and then to solve for x, I have to get x out of the cosine, which means I have to take a cosine inverse of 3 over 25. So that means I need to select for part A, letter A. Okay. Then there was a part B. It says to find the measure of angle x, so now we actually have to find it. So the next part is using our calculator. Depending on which calculator you're using, if you're using this one, second cosine of 3 over 25 equals 83.1 degrees. It says to the nearest whole number, so this is approximately 83 degrees. Okay. If you're using this calculator, you need to go 3 divided by 25 equals, and then second cosine, and you get the same thing. Okay. There's number 9. Number 10 says a unicyclist rides his unicycle across the stage. The wheel. A wheel is a circle. Wheel has a diameter of 3 feet. So we know across, through the center, the total from edge to edge is 3 feet. Which means that the radius would be half of that, wouldn't it? Half of 3 is 1.5. So the radius would be 1.5. Okay. Continuing on, it says, and the distance he rides across the stage is 50 feet. So the total distance, that would be arc length, is 50 feet. It's arc length because we're dealing with distance with a circle, okay? All right, so now it says, what is the angle? We're looking for theta, okay? In radians, that the wheel turned in rolling that distance round to the nearest whole number. So the arc length formula is S equals theta times R. We have S, so we're gonna plug that in. Don't know theta, times R, the radius, they gave it to us in a hidden way. They gave us a diameter, which means the radius is half of that, so need to multiply by 1.5. Well, to solve for theta, I'm gonna need to divide both sides by 1.5 to undo that multiplication there. And then in my calculator, it's just gonna be 50 divided by 1.5. 33.33, so it said round to the nearest whole number, so theta is approximately 33 radians. And 33 would be what you would type into the box. That's number 10. Number 11, it's a matching one where you have to match the inverses. So you would have to show your work, 6x plus 8, there's 1. There's only 3 of them here. 2x minus 10. I'm just copying them down. And we're gonna Freaky Friday. Step number 1, change f of x to a y. Step number 2, Freaky Friday. Switch the x and the y's places, solve for y. So that means we need to subtract 8 first. So x minus 8 equals 6y, and then we need to divide both sides by 6, but I like to divide everything by 6 individually. So, and when there's no number in front of a letter, you assume it to be a 1. So y equals 1/6 x minus 8 and 6 have a 2 in common. 8 divided by 2 is 4, 6 divided by 2 is 3. So there's the first one to match it with. So it matches with the x minus 8 all over 6 one. And then this one, same thing, y equals 2x minus 10. Freaky Friday. Add the 10 because we got to solve for y. X plus 10 equals 2y. I'm running out of time, that's why I'm rushing. Divide everything by 2. So immediately you see that, because they didn't simplify it, they just left it like this. X plus 10 all over 2. But when I split it, it would be y equals 1/2 x plus 5, because 10 divided by 2 would be 5. Okay? And then the last one, change f of x to a y. Freaky Friday. So x equals y plus 5 over 4. And then we got to undo what's been done to the y. So multiply by 4 to get it out of the denominator. So 4x is equal to y plus 5. Subtract the 5, so y equals 4x minus 5. And there's your drag and drop. That's number 11. Number 12. We've got to solve square root of x plus 2 plus x equals 0. Okay, so let's see. We need to get the radical isolated, so I need to subtract x. So square root of x plus 2 equals negative x. And then I need to undo the radical, which means I've got to square both sides. Some of you guys keep forgetting to put parentheses. And the x plus 2 comes out. Negative x times negative x is a positive x squared. That's where you guys are forgetting. You're losing that negative that way. You're supposed to lose the negative that way because the negative times negative is positive. Anytime you get an x squared, a quadratic, you need to move everything over on the same side as it and equals 0 on the other. So x squared minus x minus 2, and then we're going to use product sum to finish this off and get a solution. So let's see, the product is -2, the sum is -1. It's got to be 2 and 1, and the 2 should be negative because -2 plus 1 equals -1. So these are the droids I'm looking for. It's an easy trinomial, so x minus 2x plus 1. Break them apart, set them each equal to 0. X equals 2 and x equals -1. And then you need to check them. So if I plug in a 2, 2 plus 2 is 4. The square root of 4 is 2, but 2 plus 2 does not equal 0. This one doesn't work. That's extraneous. Let's try the -1. -1 plus 2 is 1. The square root of 1 is 1. 1 plus -1 does add up to 0. So that one is our solution. Number 13 is a graph. So we're just going to pick the one that we're selecting. So on number 13, it says a function is graphed on the coordinate plane. Select the function that is graphed on the coordinate plane. So remember, all parent functions start at 0, 0. This one was shifted to the left 5 and up 2. So I need to see an x plus 5 and a plus 2 on the end. That one says -2. This one says plus 5 plus 2. So B was the correct option on that one. So for 13, you would just put B, because there's really nothing to write for that one for real this time. And then that's 13 questions. Yay, made it to the bell. Woohoo!